Have you ever wondered how Docker packages can streamline your workflow? Welcome to the fascinating world of Docker, an open platform that simplifies the process of developing, shipping, and running applications. Docker packages, an integral part of this platform, are revolutionizing the IT industry. Imagine a universe where every application runs in its own isolated environment, with all its dependencies neatly packaged together. That's exactly what Docker packages offer. They encapsulate everything an application needs to run: the code, runtime, system tools, libraries, settings, into a single unit. This not only ensures consistency across multiple development and deployment cycles, but also significantly reduces the time and effort involved in setting up environments. Docker packages are like magic toolboxes, empowering developers and IT professionals to focus on what they do best: creating and managing amazing applications. So, whether you're a seasoned developer or a curious newbie, Docker packages hold immense value for you. Stay tuned to unravel the mystery behind Docker packages. Before diving into Docker packages, let's understand Docker itself. Docker is a popular open-source platform that allows developers to automate the deployment, scaling, and management of applications. It does this by utilizing containerization, a lightweight form of virtualization. With Docker, you can package an application and its dependencies into a single, self-sufficient container, which can then run on any system that supports Docker, regardless of any customized settings that system may have. Now, why is Docker so important? Well, it simplifies the process of managing and deploying applications, eliminating "it works on my machine" issues. This means you can focus more on writing the code that powers your business and less on system administration. Docker also makes it easier to create reproducible environments, which is crucial for testing and debugging. The benefits are clear. Docker allows for faster, more reliable, and easier software delivery. Now that we know what Docker is, let's move on to Docker packages. So what exactly are Docker packages? You may ask. Well, let's delve into that. Docker packages, also known as Docker images, are the fundamental entities in the Docker ecosystem that contain everything necessary to run an application. Think of them as a self-sufficient software unit. It's like a mini computer with its own operating system, software, and application code, all neatly packed and ready to run anywhere Docker is installed. These packages are created from a set of instructions known as a Docker file. This file defines what goes on in the environment inside your container, including specifying the base operating system, installing necessary applications, and defining the commands to run the application. It's like a blueprint for your application's environment. Now, why are Docker packages so important? The answer lies in their portability and consistency. Docker packages ensure that your application runs the same way, regardless of where it's deployed. So whether you're running your application on your local machine, a testing environment, or a cloud server, you can be sure that it will behave exactly the same way. This eliminates the age-old problem of "it works on my machine," which can be a nightmare for developers and operations teams alike. Furthermore, Docker packages are lightweight and efficient. Since they share the host system's kernel, they don't need a full-fledged operating system inside them. This makes them significantly smaller and faster than traditional virtual machines. One more cool thing about Docker packages is that they are version-controlled and shareable. You can push your Docker images to a Docker repository like Docker Hub and pull them whenever you need. This allows for easy sharing between teams and also helps in tracking changes and updates to your application's environment. Docker packages also promote the principles of microservices architecture by allowing each service to be packaged into its own container. This makes managing and scaling applications much easier and more efficient. In essence, Docker packages are the building blocks of Docker. They encapsulate your application into a neat, portable, and efficient unit, ready to be shipped and run anywhere, anytime. Now, you might be wondering how to use these Docker packages. Well, let's delve in and explore the step-by-step process. It's quite straightforward once you get the hang of it. So let's start by installing a Docker package. To do this, you'll need to run the docker pull command in your terminal, followed by the name of the Docker image you want to install. This command tells Docker to fetch the image from the Docker Hub registry. Once you've installed your Docker package, you can run it using the docker run command. This tells Docker to create a new container using the image you've just installed and then run that container. If you want to see all the Docker containers that are currently running on your system, you can use the docker ps command. It's also worth noting that Docker images are read only. So, every time you create a new Docker container, a writable layer is added on top of the image. You can make changes to this layer while your container is running. However, once you stop the container, all changes to the writable layer are lost. To save these changes, you need to create a new image using the docker commit command. Now, what if you want to share your Docker image with others? Docker makes this easy too. You can push your Docker image to Docker Hub using the docker push command. Before you can push an image though, you'll need to tag it with the docker tag command. Finally, if you want to remove a Docker image from your system, you can do so with the docker rmi command. This will delete the image and free up disk space. These are some of the basic commands and operations you'll use when working with Docker packages. Of course, Docker offers many more advanced features and commands, but this should give you a good starting point. And that's how Docker packages are utilized. Practice these commands, experiment with different Docker images, and before long, you'll become a Docker pro. Scene script. Let's see Docker packages in action. Imagine you're working on a project that requires the use of several different software tools. Each one of these tools comes with its own set of dependencies and system requirements. It can be a real headache to make sure that all these different tools can operate smoothly together on the same system. Now, let's introduce Docker into this scenario. Docker packages, or containers as they're often called, encapsulate everything an application needs to run, including the code, runtime, system tools, and system libraries. This means that each software tool you're using for your project can exist within its own Docker package, completely isolated from the others. So, how does this look in a real-world scenario? Let's say you're developing a web application. This application might require a specific version of Python, a particular database software, and a certain web server. Instead of installing all these components directly onto your system and potentially causing conflicts with other projects or applications, you can package each component into a separate Docker container. You'll start by creating a Docker file, which is a text document that contains all the commands you would normally execute manually to build an image. Your Docker file for the Python component, for instance, might specify the version of Python you need and any Python libraries your application depends on. Next, you'll use the docker build command to create a Docker image from your Docker file. This image is a lightweight, standalone, executable software package that includes everything needed to run your Python component, including the runtime, system tools, libraries, and your code. Finally, you run the image inside a Docker container. The container runs completely isolated from your host system, ensuring that your Python component can operate without interfering with any other software on your system. You'll repeat this process for each component of your web application, packaging each one into a separate Docker container. The end result? A streamlined workflow, where each component of your application operates independently, reducing the risk of system conflicts and simplifying your development process. As you can see, Docker packages can significantly streamline your workflow. Let's summarize what we've learned today. Docker packages have emerged as a game changer in the realm of software development, revolutionizing the way we build, ship, and run applications. These handy little containers allow us to package an application and its dependencies into a single, self-sufficient unit. This means that our applications can run seamlessly across different computing environments, be it a personal laptop, a public cloud, or a private data center. We've delved into the nuts and bolts of Docker, understanding its core principles and functionalities. Docker's power comes from its simplicity and efficiency. It uses fewer system resources than traditional virtual machines, making it a lean, mean, software-running machine. We've explored Docker packages in detail, dissecting their structure and components. A Docker package is like a shipping container for your software. It includes everything your software needs to run: code, runtime, system tools, system libraries, and settings. This ensures that your software will always run the same, regardless of the environment it's in. We've also learned how to use Docker packages. Docker's command line interface is user-friendly and intuitive, making it easy to create, run, and manage Docker packages. With a few simple commands, we can build a Docker image, run it as a Docker container, and even share it on Docker Hub for others to use. We've seen Docker packages in action, demonstrating their flexibility and adaptability. Docker packages can simplify complex software installations, streamline development workflows, and facilitate continuous integration and continuous deployment pipelines. They're a boon for both developers and system administrators alike. In conclusion, Docker packages offer a streamlined and efficient approach to software development and deployment. They encapsulate our applications and their dependencies, ensuring consistent performance across various platforms. They simplify software installations, boost development workflows, and facilitate continuous integration and deployment. Remember, Docker packages are your friends in the world of software development. So, don't hesitate to embrace them and let them help you navigate the choppy waters of software development with ease and efficiency.